How about some properties of radicals? If you'll notice, this page has a whole lot of just math mumbo jumbo on it. What I would like for you to do is pause the video, have a read, see if you can understand this, and then restart the video as I explain it in English. Okay, so case number 1. This is talking about whenever A is a non-negative real number. That just means that A, the radicand, the part that's under the radical, is positive or 0. That's what non-negative means. It means positive or 0. So if you have an even radical or an even root, let's say we take the 4th root of something. Let's say sorry about that, give me just a second. Let's say the 4th root of 16. Well, the 4th root of 16, by the way, remember this has to be positive if this is even. So the 4th root of 16 is equal to 2 because 2 to the 4th power equals 16. Okay? So what if we had the 4th root of a negative number? The 4th root of negative 16. We would think that that would be negative 2. But let's try. Is negative 2 to the 4th power equal to negative 16? Well, whenever you raise a negative to an even power, it actually comes out to be positive. So this is not true. That's why your radicand needs to be positive if your index is even. Okay, so what if we have an odd index? By the way, this little number is called an index right here. That's what I'm talking about. Let's say we have the cube root of 8. Well, the cube root of 8 is 2 because 2 cubed is equal to 8. Okay, so what about the cube root of a negative 8? Is this a negative 2? Well, let's see. If you cube a negative 2, do you get 8? Sorry, do you get negative 8? You do. So in case number 2, if n is odd, then the sign of the answer will be the same as the sign of A. It's a pretty interesting little property there. You do need to know these definitions. You need to know what an index is. The radicand is the stuff underneath, and the radical sign is the actual sign itself. Okay, now I know that you guys already know how to find square roots on your calculator. So I want to show you something that one of my students taught me a long time ago, and that's called the prison method. Now I want to warn you, it's pretty morbid, but it really works, and it helps a lot of people understand. So what I would like for you to do, even though we know what the square root of 16 is, let's go ahead and break this down using prime factorization. Now with prime factorization, you can use any two numbers that multiply to give you the number above it, except you never want to use 1. So let's say we could use 2 times 8, or we can use 4 times 4. Either one works. So I'm going to go ahead and use 4 times 4. Well, 4 is not prime, so I'm going to break those down. 4 will break down into 2 times 2, and this 4 will break down into 2 times 2. So what we have is the square root of 2 times itself 4 times. Now, this is how the prison method works. The radical is the prison, and all of these factors are the prisoners. Now, these prisoners are trying to escape. Your index tells you how many have to be in a group for them to escape. Well, remember, if you don't see an index, it's a 2. So that means for this prison, they have to escape in groups of 2. So we're going to put them together in groups of 2. Okay? Now here's where the morbid part comes in. When prisoners try to escape, the guards come out and they start taking people out. So, in this group, when they escape, only one survives on the outside. In this group, when they escape, only one survives on the outside. Well, what do you get from the ones that escaped? 2 times 2 is 4. The square root of 16 is 4, which we pretty much already knew. Okay, I told you it was morbid, but it does work. So what about this one? We have the square root of a negative number. Well, we just talked about that on the previous page. We would think that it would be a negative 4. But is negative 4 squared equal to negative 16? No, it is not. That means this particular answer is actually not real. We're going to talk more about that when we get into some complex and imaginary numbers. So if you have an even root of a negative, just for now, you can just tell me that it's not real. So how about this one? Is it the same? Well, this one is different because the negative is on the outside of the radical. In this case, the negative just stays there. And the square root of 16 we've already determined to be 4. Oh boy, here we go. Alright, so what we want to do is I'm going to just use the prison method on all of these because it seems to be the way my students learn it the best. So for this one, we have the 5th root of negative 243. It is okay to have the 5th root of a negative. So let's go ahead and start breaking this down. You have 243. I know 3 will go into 243 81 times. So we have 3. 81 will break down into 9 times 9. 9 will break down into 3 times 3. So it looks like what we have is the 5th root of negative 1 times 3 times itself 5 times. But remember, your index tells you how many have to be in a group to escape. So all 5 of these will be escaping together. But no matter how many are in a group, the sad thing is only one survives. So from this group we only have one survivor, but we still have this crazy little 5th root of negative 1. Well, is this true? Is negative 1 to the 5th power equal to a negative 1? It is, right? So this is really just a negative 1 right here. So we could say 3 times negative 1 is negative 3. So the 5th root of negative 243 is negative 3. Okay, so how about B? We have the square root of negative 81. The square root of a negative, that's an even root of a negative. That's not real. How about C? We have the negative square root of 81. Well, the square root of 81 is 9, but since the negative is in front, we have to keep that negative. How about the cube root of 0? That's right, it's 0, because 0 cubed is 0, right? Okay, how about the nth root of 1? If n was any number in the world, the nth root of 1 is just 1. Why is that? Because 1 to any power is 1. 1 to 100 means 1 times 1 times 1 times 1, 100 times. So it's still just 1. Oh, so how about the nth root of a negative 1? What does that even mean? Well, first of all, can n be even? For now, it can't, right? So if n is odd, then the nth root of -1 would be -1. But if n is even, then this would not be real. It would actually be imaginary. Okay, let's look at f. We have the cube root of a negative. Is that okay? Yes, that is okay. So then we need to figure out what's going on here. We have an 8 and a 125. Well, 8, probably going to run out of room here. We have 8, which breaks down into 2 times 4, 2 times 2 times 2. Well, we're grouping them in groups of 3. All 3 of these would get to escape, but only 1 survives. And what about this negative? That's right, it's going to be a negative. So we have a -2 on the outside. Well, how about the 125? That's going to be 5 times 25. That's 5 times 5 times 5. All 3 of these escape, but only 1 survives. So the cube root of -8 125ths is -2/5. G and H are pretty cool little examples. We have the 5th root of something to the 5th power. Now keep in mind, this negative is not raised to that 5th power. So if you wanted to, you could rewrite that as the 5th root of a -1 times a pi to the 5th power. But we already know the 5th root of -1 is -1. Well, how about the 5th root of pi to the 5th? Pi to the 5th means 1, 2, 3, 4, 5. They're escaping in groups of 5, but only 1 survives. So it's -1 pi, or just -pi. So what could have been a shortcut here? The 5th root of -pi to the 5th, the index and the exponent are opposites. They're going to cancel each other out. Okay, the only thing you have to worry about is if you have an even index and or an even power. You need to take care of what's under here first. So whenever you have a -4, see this negative is raised to the -4. That's going to end up being a positive. The 4th root of, well, what is -4 to the 4th power? It is 256. Well, we already know that that's 4 times 4 times 4 times 4. Or you can say it's the 4th root of 4 to the 4th. And the index and their power cancel each other out, which means you just get 4.